These are the 8.2 part 2 notes, and we're going to continue with the law of sines. So just as a law of sines reminder, we have A over sine A is equal to B over sine B, which is equal to C over sine C. Again, our book presents it this way, and this is kind of the way I do the work. Sine of A over A is equal to the sine of B over B, which is equal to the sine of C over C. And again, when we're talking about these, we're talking about opposite sides. So C is opposite the angle C. A is opposite the angle A. And B is opposite the angle B. So we have all of these little facts here. And again, this is one equation that actually represents three equations. We can say sine of A over A is equal to sine of B over B. Sine of A over A is equal to sine C over C. And sine B over B is equal to sine C over C. We've already done one example on if you're given two sides and an angle. Now I'm going to jump back and do the last two types of triangles we can have. This gets a little bit more complicated. You have to think through this when you have two sides. You always have to check. It's not the hardest thing to understand. I'm going to kind of teach you a little bit of a trick. I'm not the world's happiest about teaching you a trick, but at the same time, I do want to make this a little bit easier. So I've got two sides here. Solve the triangle. A is equal to 6, B is equal to 8, and then A is equal to 35 degrees. So I set this up. Sine of 35 over 6 is equal to the sine of B over 8. All I have to do here is multiply both sides by 8. I could cross multiply, but that's unnecessary, especially when I have my numerator here. So then 8 times the sine of 35 divided by 6 is equal to the sine of B. I go ahead, I go to my handy dandy calculator, and I plug in 8 times the sine of 35 and divide it by 6. And my handy dandy calculator says that the sine of B is equal to 0.765. Now, to figure out what B is, I take the inverse sine of this value. And again, this is just plugging it into my calculator. This is not doing this in your head. This is not any math. This is a calculator thing. So I plug that into my calculator, and I find that my angle is 49.9 degrees. So B is equal to 49.9 degrees. Well, now what I need to do is check, because again, sine could be positive in quadrant 2 or quadrant 1. I already have a quadrant 1 angle for it, and that quadrant 1 angle is 49.9 degrees. But theoretically, it could also be a quadrant 2 angle, and that quadrant 2 angle has to be 49.9 degrees away from the x-axis. And I figure that out by doing 180 minus 49.9. Now in my answer key, you're going to just see me do that 180 minus 49.9. I don't draw out the quadrant like I did up there. The quadrant is the explanation of why I'm doing this. It's why I need to go through and see if there's a second angle, because since sine is positive in quadrant 1 and 2, and quadrant 2 are angles less than 180 degrees, that means I could totally have an angle which falls in quadrant 2 that's not being reported to me. So I have to figure out, okay, maybe there's two triangles that work here. So I go through and I do 180 minus 49.9, and I find that that is a 130.1 degree angle. Well, now I have to add that 130.1 degrees plus the 35 degrees. If this is less than 180, then I've got two triangles. And when you know it, 130 or 165.1 is less than 180. So that means B is also going to be 130.1. I've got no way to determine which one it is. There's not enough other information given to me in this problem to say, oh, it is definitely one triangle versus the other. I don't have that information whatsoever, so I can't assume that it's one or the other triangle. If both of the triangles work, then I have to solve for both triangles to see which. And then if this were a word problem, I could use some inference or I could use some other information to maybe help me figure out what I'm actually talking about here. Like if it were to say, and side B is the largest side, well then it's obviously going to be the 130.1 degrees, or B is the smallest side, etc. But if I don't have a real world application, I'm just being given the numbers, I have to solve for both. So we've got two triangles here. So I'm going to start with triangle 1. Triangle 1, I'm going to do the 49.4. So that means I've got 180 minus 49.9 minus 35. And that means that my angle C will be equal to, plugging it on the handy dandy calculator right now, so just give me a second. It's going to be equal to 95.1 degrees. So then I'm going to do the sine of 95.1 over C is equal to the sine of 35 over 6. 6 times the sine of 95.1 is equal to C times the sine of 35. And then 6 times the sine of 95.1 divided by the sine of 35 is equal to C. Now you're going to see this. I'm going to jump this step that I'm highlighting a lot in my answer key. I don't do that. I don't cross multiply across my proportion that often in the answer key. I do it for the first couple. But really quickly, I see a pattern. I get really used to this pattern. I understand that almost every one of my answers ends up this way. I have to do this at some point. And I'm just so used to plugging it in, especially after I did the 8.2 part 1 homework. I jump this step frequently. It's unneeded. I can jump straight to the 6 times the sine of 95.1 over the sine of 35. You're going to see that a lot, so make sure that if you're kind of confused that that's what's happening. I go ahead and I plug this into my calculator, and I find that C would be equal, still in highlighter, C would be equal to 10.4. I stop and I do a quick little mental check of myself. Okay, in this case, B is larger than A. Gives me a side larger than A. A is my smallest side, gives me a side smaller than B. C is my largest side, gives me something larger than B. Even proportionally, it starts making sense, so I call that good. Triangle 2, I'm just going to do 180 minus 165.1. I already know that it's 165.1 because I've already added angle A and B together to figure out if it could even exist. And I find that this is a 14.9 degree angle for C. And then I set up my same formula. The sine of 14.9 over C is equal to the sine of 35 over 6. So then C will be equal to 6 times the sine of 14.9 over the sine of 35. And again, this is where I jump that step. I see my cross multiplication and division that has to happen. So I go ahead, I plug that in to my handy dandy calculator. And I find that I'm looking at a side length of 2.7. So I've got a side length of 2.7 here. And again, that makes sense. C is my smallest angle in this case. And when you consider that I've got a side length of 8 for an angle of 130 degrees, a side length of 2.7 for an angle of 14.9 degrees makes sense. It's my smallest. All these triangles work out. I just did a quick mental check. That doesn't even require plugging anything back in. I'm just doing a brief, does this even begin to make sense? Yes, it does begin to make sense. The side lengths match up where they should match up. And it's cool. I say that's good and I move on. Example 2, I've got solve the triangle A is equal to 2, C is equal to 1, and the angle C is equal to 50 degrees. So again, right away we're going to set up, we're going to try to figure out what our other angle is here. I've got the sine of 50 over 1 is equal to the sine of A over 2. And then when I cross multiply, that just means 2 times the sine of 50 is equal to the sine of A. So I go ahead and plug this into my calculator. And I find that 2 times the sine of 50 is 1.532, and that's equal to the sine of A. Well, this creates an issue for me because this would suggest that A is equal to the sine inverse of 1.532. Well, we've already learned that sine of x, if we write f of x is equal to the sine of x, it's got a range of y has to be greater than or equal to -1, and it has to be less than or equal to 1. We've also learned that if I've got a function f of x is equal to the sine inverse of x, well, then that means your domain has to fall between -1 and 1. So once I see a number greater than 1 here, once I see that this is 1.53, it's above 1, I can't do this. And you can even go ahead, plug this in on your calculator, and it's going to give you back an error message. I'm even going to plug this in to tell you what that error message is. And that error message, it says error domain. So it lets you know that, oh, this number doesn't even fall in the domain. This is an impossible calculation. So because of that, we say that there's no triangle. So this is the book giving you some values that don't exist, in an attempt to maybe like make you second guess yourself if things aren't working out, but there is an option that there's no triangle. Your homework for tonight is textbook page 516. It goes over everything where you have 2 sides and 1 angle, 11 questions on it. All 3 of these are going to show up. You're going to have 1 triangle, which we learned about in your previous notes. You're going to have 2 triangles, which you learned about today, and you're going to have no triangles, which you learned about today. I'm going to have a video answer key to go over some of them, just to make sure that you know everything. Any questions or concerns, please reach out sooner rather than later, and have a great night.